Hey guys, Mr. Barnes here again. Take number 3 of this video. Um, Trying to solve the second type of trig equations that we encountered in class. And this is the type where it sort of looks like a complex trinomial. So again, our first step with this one is we sub out sine. So we said let sine is equal to m. Again, choose something other than x and theta. We don't want to get ourselves confused, so I choose m. So we have 2m squared minus m minus 1 is equal to 0. And recognize again, your answer should be in terms of radians. So when we if we do it in degrees, we make sure our final answer, is in radians. All right, so we solve this thing using either Joe's or decount. Okay, again, whatever your preference is, doesn't matter. I'm going to use Joe's because I think it might be the most popular method. Right here, again, we got to make sure we multiply to get -2 and add to get -1. So the numbers that do that are -2 and 1. Hang on one second. My cat is doing something that I had to... All right, I'm back. My cat is okay. Here we go. Now, with Joe's method, the thing to remember is you've got to divide by the coefficients. You divide both of these by 2. Okay? And we get -1 and 1/2. So then what we do, we write it in our factored form. We go m minus 1 to m plus 1 is equal to 0. So remember, we don't want any fractions in our factored form here, so we write it like this. Okay. So then what that leads us to do, we remember our 0 property, only way this can equal 0. One of these sets of brackets is equal to 0, so we go m minus 1 is equal to 0, so that's m equals 1. And then 2m plus 1 is equal to 0, so that's m is equal to -1/2. And again, the beauty of Joe's methods is it doesn't take you too long to realize what your solutions are. It's just the opposite of what these two numbers that we get here are. So again, this sort of process here is, it's important, but it's not really necessary for our answers. All right, so recognize that we have m is equal to 1 and m is equal to -1/2. So we have to recognize that that's also equal to sine. Okay, so in fact, what we have is sine theta is equal to 1 and sine theta is equal to -1/2. Okay, so again, what I want you to recognize is we have two mini problems here to solve. Okay, so I'll solve this one first because this one's a little bit of a special case here. So we take our RA, it's going to be equal to, first of all, recognize sine theta is negative. RA is equal to sine -1, and again, my related angle, sine is positive. We want something between 0 and 90. That only occurs in the first quadrant, so we have to take sine to be positive. Okay, so sine is 1/2, and that gives us 30. Sine of -1/2 is 30. All right, so my related angle is 30. So we're looking at where is sine negative? C, A, S, T. So it's negative in C and T. So my theta is going to be 180 plus RA and 360 minus RA. So that comes from our CAS rules. This is RA. This is 180 minus RA, 180 plus RA, 360 minus RA. And then we have 180 plus 30. So that's 180 plus 30, which is 210. And then 360 minus 30, which is 330. And then recognize that's in degrees. We have eventually we'll change that to radians. And over here we have sine theta is equal to 1. So a couple different ways we can do this. We could think of our unit circle. And we think of the 3 points on the unit circle. So we got this point, and this point. So if we have our unit circle in this Okay, if we have the unit circle in there like this, we got our 4 points on it. Our 4 points are, this one is 1, 0. This one is 0, 1. This one is -1. This one is -1, 0. And this one is 0, -1. Also recognize, guys, that x is sine, or sorry, x is cos, y is sine. So we're looking for where sine theta is 1. This is a 1 here. So we're looking for basically where y is equal to 1. Okay, sine theta, y, this is unit circle, radius is 1. So we're looking for this point right here, and we're thinking, what angle is that? Well, that is a 90-degree angle. Okay, so in fact, our theta in this case would be equal to 90. Again, if you wanted to follow this routine, you could, and I'll do that for you. So you're thinking, what's my RA? So again, technically, an RA is between 0 and 90, so we go sine theta of -1, and that actually gives you 90. Okay, that actually gives you 90. So then you're thinking, where sine is positive, where's sine positive? Well, sine is positive in S and A. Well, S or A is just RA, so RA would be 90, or theta would be 90, and then here 180 minus RA, which would be 180 minus 90, so which gives you 190. So again, you get theta is equal to 90 anyway. Okay, so both of these ways are acceptable, whichever works for you. Preferably, this would be the easiest way to do it, I think, just to know that that's a unit circle, and that's what happens. This is, 90, we have cos 0, sine is 1 at 180, cos is -1, sine is 0. Down here, cos 0, sine is -1, that's 270, and then back around continuously. Okay, so now we have the situation where we have our thetas to be 90, 210, and 330. Okay, so what I want you to do here is convert these to degrees. So remember how we do that. So we have to take our degrees and multiply by pi over 180. So 90 is one you shouldn't really know anyway. But basically what you get is 90 divided by 180, that's a fraction that you can reduce, which would be pi over 2. And then 210 times, all right, 210, I made a mistake there, I gotta fix that. So 210 times, again, same sign dance, pi over 180. So that becomes 210 over 180 is a fraction, is actually 7 pi over 6. And then you got 330 times pi over 180. That's going to be 11 pi over 6. So that's just the conversion factor. Again, if we had degree radians, we want to convert degrees, multiply by 180 over pi. All right, so you present your final answer in terms of pi. So my final answer is pi over 2, 7 pi over 6, and 11 pi over 6. So that would be my final answer. Okay? And again, guys, if you wanted to avoid this conversion, you can always find your RAs in terms of radians. Absolutely, that's free to do. If you're using your calculator, make sure you get a calculator in radian mode. And that's pretty much it, guys. So thank you very much.